What we're working on in this video is section 6.2, bisectors of triangles. Last lesson we learned about angle bisectors. Spell it right. Angle bisectors and perpendicular bisectors. Today what we're going to do is we're going to work with those, but now they're going to be inside triangles. So remember, an angle bisector cuts an angle in half, and a perpendicular bisector, it starts off by cutting a segment in half, but it's perpendicular. So we're going to be working with those two things today. Okay. When you have geometry terms or geometry things, one of the things we need to know is what concurrent is. And concurrent just means when things overlap or intersect. And specifically, the point of concurrency is where things overlap. That's the actual intersection point. The circumcenter is the point of concurrency for perpendicular bisectors. And then for angle bisectors, when you have an angle bisector, they make an incenter. And so here's kind of the definitions and things. So perpendicular bisectors of a triangle are concurrent at the circumcenter. And so these are each the perpendicular bisectors go, this would be it. We'll draw them. And if I kind of draw up, and then this one, and then what happens is the other one's here, but the reasons you have this line here, this A, B, A, C, and AD, is because those are the radius of this circle. So it touches here, here, and here. And so that circle goes around that and has that radius. So each of those distances are equal. The perpendicular bisectors aren't really used except to find that point. Once you find that point, you can kind of erase those, and that's why they weren't on that picture. Okay, so the angle bisectors, when you have angle bisectors of a triangle, they're concurrent at the incenter. And so this is actually that point. They cross right here. Right there, and so those are the actual angle bisectors. Unlike over here, the lines drawn were not the angle bisectors. Before we actually do problems with math and numbers, what I want to do is I just want to practice drawing and finding these things. And so if I draw just a regular triangle, let's see if we can find the perpendicular bisectors. Now it's not going to be super accurate because we're not folding or measuring, but if I find the midpoint here, and then I try and draw a straight line, and I find the midpoint on this side, and try and draw a straight line, and then I find the midpoint on this side, and try and draw a straight line, you should notice that they should all cross, and it's a little off. So because I'm not folding it and doing as accurate as possible, I'm going to try and cheat a little bit. There we go. So this right there, that's the circumcenter. If I had you measure and fold and do things, you can find it exactly. I do want to say sometimes the circumcenter is inside the triangle, outside the triangle, or on the triangle. So it can be in different locations. All right, and then angle bisectors. Let's try for a big, obtuse triangle. So I'm going to try and cut this one in half. Cut this one in half. And then this one, it's supposed to go through there, so I'm going to kind of cheat and make it go through there. But then that's the incenter, and the incenter would go right here. It would be able to make a circle right in the center. Okay? So we'll practice doing those skills, being able to draw perpendicular bisectors and angle bisectors. But now let's go ahead and look at the math and what happens with numbers. Okay, the first problems we're doing is dealing with the in-center. So that means these are angle bisectors. And what that would look like is I would have a triangle and the circle's perfectly inside. Okay, so now n to d is 2x minus 5, and n to d is negative 2x plus 7. Well, those are equal because those are the radius of the circle that's inside. So I'm just going to set those things equal to each other. So 2x minus 5 equals negative 2x plus 7. I'm going to add 2x on both sides. So I get 4x minus 5 is equal to 7. Uh-oh, we're having some lag issues. And then I'm going to get rid of a minus 5 by adding 5. So 4x is 12. And then I'm going to divide by 4 to find that x is 3. Now the problem is the question was not asking for 3. It was asking for this. Right there. I don't have a number on there. So how am I supposed to find out what that is? Well, remember the in-center is inside, so those 3 segments are all radiuses, so they're all the same. So I'm going to pick one of those two, it doesn't matter, I'm going to plug in 3. So I'm going to pick this one because it doesn't have a negative, so it's going to be 2 times 3 minus 5, so that's 6 minus 5, so NF is 1. So each of those segments, if I plugged it in, I would get a 1. Okay, so I'd like you to go ahead and try number 2 on your own, and then once you have it, press play so you can check to see how you did. Okay, welcome back. You should have noticed that you were given NG and NH, which again are equal, so I'm going to set those equal to each other. And so I'm going to minus x on both sides, so I get 1x minus 6 is negative 1. Add 6 on both sides, so I get x is 5. Now it's the same idea as over on the other one. I'm looking for n to j. It doesn't have a number there, but I should know that it's equal, so I'm going to pick one of those two. I'm just going to pick the x minus 1. So n to j is equal to 5 minus 1, because I plugged in 5 for x in that first one. And so nj is 4. All right, the second set of problems we're dealing with is perpendicular bisectors. And I know they're perpendicular bisectors because I have midpoints and perpendicular lines. So midpoints and perpendicular lines. So the question is asking me to find P to A. Well, remember for perpendicular bisectors, the circle goes exactly on the outside. And so essentially what happens is these are my 3 radiuses right here. And so if I'm looking for PA, it's the same as this one, PB, so it has to be 13. Because all radiuses have to be the same. Okay, so let's look at number 4. P to S. Where's P to S? P to S, here it is right here. Two, if you notice P to S is the same, it looks like it's the same as this, but it's not because it's perpendicular bisectors. Look at what's making marks. These are angle bisectors. And so that tells me that my circle would be on the inside. And so each of those lines are my radius. And so SP or PS is 8. So it's different than over here, because I don't know anything about where the perpendicular bisects when they intersect what they are. But angle bisectors, I know when they intersect, the distance from that intersection to the triangle is equidistance. All right, the last one, take a look and see if you can see if it's a perpendicular bisector or angle bisector, and then see if you can find that missing measure of NF. Okay, well hopefully you said it was an angle bisector. And I know it's angle bisector because look at all these angles cut in half. And so now, because it's an angle bisector, that gives me an in-center, so the circle's inside. So these radiuses are the same. So that tells me if N to E is 2, then N to F is 2 also. So the important thing to know is when you're going to have a circle inside versus outside. Remember, angle bisectors is in center, so the circle is inside. Perpendicular bisector is circumcenter, so the circle's on the outside.